All right, class. Now we've gone through that presentation on data analysis, experimental design. I want to work on applying that to an actual data set. So we've got on this page here, this Excel sheet, an example tab. That's this data set here. Maybe color that green. Green's a good color. We have a data set for practice as well. Now, the practice is going to be just for you to do. I won't do anything on that with this video, but we will spend a lot of time in this video on our example tab. Now, with this experimental design and data analysis discussion, I'm expecting you to be set for the rest of this semester. I'm expecting you to be good to go with data analysis for image analysis, for the photosynthesis and respiration data, for the plant hormone work, and for the plant physiology work, right? Anything that you see an activity sheet with, you will be expected to do data analysis. And this won't be something that we'll go over as a class when those points come up. So take your time on this. We'll go through all the basics of Excel. And if you don't have Microsoft Excel downloaded, the Microsoft Office suite is free. Please have that downloaded. You're going to need it. Google Sheets won't do the trick. So we're going to go through this. Now, some basics that we'll see on this Excel sheet. We can add two numbers. If we have values 1, 3, 5, 7, 9, we can generate something like a sum by doing this equals button here. And we can highlight all of them. That wasn't right. We can do equals sum. Sum's that function that we're looking to get. Then highlight all of them, if we do this correctly now. And we get 25. 1 plus 3 plus 5 plus 7 plus 9 is indeed 25. And I'll even write sum. Now, if we want to take the difference between two values, we can do equals 9 minus 7. And that gives us 2. Now, if we want to take the sum of two numbers, two selected numbers, we can do equals 1 plus 3 plus 5. Oh, we're getting crazy now. Plus 7 plus 9. And again, we get 25. Easy enough. So we can enter those manually. Those are some key features. We can also multiply. We can do equals, I don't know, this value, C22, highlight cell value number 7, times 5, that's C21. Click enter. Okay. We can divide. We can do equals 9 divided by 3. Okay. I think this part makes sense, right? Hopefully you all are familiar enough at this point. We can get crazy with our mathematics here. We can do equals, and then put some brackets in. We can do 9 plus 5, close that bracket, divide that. This just goes by our order of operations, right? Times 7. Whatever that equation there is. And I can give you a minute to take a look at that, jot down some notes. I'm going to click enter. That gets us 24.5, right? Mess around with that as much as you will. You'll see that pops up in this box here. I can click on it and it'll pop up down here and show us what all is highlighted, where it lands on this equation. But I'm hoping you're pretty familiar with that. Some other things we can do is we can calculate means. We can do equals average, like we do with sum. Instead of using the word sum, we have average in here. We can select all of these values, put that closed back bracket on, 5, right? or you can do equals average. And maybe we don't want to include number 1 in that set of averages. We can do 3. We'll do 3, 7, and 9. We'll exclude 1 and 5 from that average. Why? Just because, right? We get 6 1/3. Easy enough. Another key function that you'll want to have on hand is calculating standard deviation. Standard deviation. Now, we talked about standard deviation in that presentation earlier, but all that's going to be is equals STDEV. Put our parenthesis up there. You can select it for, I don't know, values 1, 3, 5, 7, and 9. And there we have it, our standard deviation. So our average of these 5 numbers is 5. Our standard deviation is 3.16. Okay. Now let's put that to work on an actual data set. Now, we have this data set for 3 varieties of tomato that were grown up here in Chico. We have the variety name in column B, 3 varieties listed. Replication number in column C, we have 4 replications. And if you don't remember what the replication is, I'd go back and check out that video, but we grew 4 plots of each variety, right? Then from each of those plots, we calculated a tomato yield from it. And we also calculated something called Brix. Now, Brix is this kind of measure of sweetness. Higher the Brix, the sweeter the fruit. Easy enough. So we can hypothesize just from looking at this data, or maybe from what we knew previously, that Juliet had the highest yield. Okay. And we could maybe even make a second hypothesis that there's a negative association between yield, that amount of fruit produced, and Brix, that sugar content. So we can test that out. Now what I'm going to have you do here is start using those metrics, those Excel tools that we had down here, and plug that in for each of these. So mean yield in tons per acre, we're going to do this variety by variety. If you don't have these varieties matching when you select your data, you're not going to get the right result. Equals average. 1, 2, 3, 4. We're doing this across the 4 replications, right? That's why we have those replications. So we can generate averages that have a more meaningful story to tell. We'll do that for each of these varieties. For reps 1, 2, 3, and 4 of Juliet. Again, we're just generating these averages for tomato yield across replications for each variety. Okay, so just from first glance, we see, aha, in this table, it's clear that Juliet had the highest yield. Good. Now we're going to calculate standard deviation. STDEV. We're going to do that same thing. All 4. Okay, so those are actually pretty low standard deviations. That means that we don't have a lot of think about them as outliers in that data set. Our data set fits into a nice good bubble of data there that tells a pretty uniform story across replications. We'll do the same for our Brix. 1, 2, 3, 4. Doing the same thing across replications for each variety. We'll do the same for standard deviation. Aha! All right. So we see that standard deviation is at least some part of it is a product of that mean. The lower that mean, lower our standard deviation. Generally speaking, that's not a statistical fact, but that's a general trend that you'll see. Now, let's make a bar graph. This first graph says, graph the mean of tomato yield, and that's tomato yield for each variety. And we need to make error bars that represent standard deviation. So let's see if I can do this. I'm going to click that Insert tab in Excel. I'm going to click this Insert Column or Bar Chart button. Just a standard 2D bar graph. We shouldn't be using 3Ds. That doesn't make any sense for this data set. Just that clustered column is fine. So I'm going to click here. I did a right click on this table. Select data. I'm going to remove what's already on there. Let's start from scratch. So legend entries, we're going to do this for each variety. So that series name, you can click that up arrow, select your variety. We're going to select our series value as our mean for tomato yield. Okay. And we're going to keep that process going. Whoops, didn't select the right data there. Gotta select that variety name, don't I? You see it shows up here. And the value is the mean for that variety. Okay. Ooh. Let's redo that one. I skipped ahead on myself and made a little mistake there. And it's okay to go back and redo these, right? We'll make mistakes. Don't get frustrated. It's a lot of clicking, a lot of work at this stage of the game. We're adding each of our legend entries as a variety. We can do this a handful of different ways, but that's how I'm going to do it in this example. I've got all these up here. Looks the same as it did before I deleted it. We're going to click OK. All right. So you've got a graph. This graph doesn't tell me anything. This graph doesn't have any meaning the way it's written. So first, I'm just going to be clever and put that in this box here. Ta-da! Okay. Now we have this graph selected. I'm going to click this Add Chart Element button in the top left-hand corner. And we see we have this Chart Design tab open. Go to Add Chart Element. Go to Axis Title. We're going to add our primary horizontal and our primary vertical. Now we can make sense of what these numbers mean. So this title will be what? This is our tomato yield in units of tons per acre. Let's do that number. Great. So you've got this. If you want to get fancy, you can even go tons acre. Oops. Then home, font, superscript. And that tons acre -1, that means the same thing as we just had, tons per acre. This title, this will be tomato variety. Easy enough. Now, what's blue mean? What does orange mean? What does gray mean? I'm going to delete this now, get that out of the way. Well, we'll go back to chart design, add chart element. Let's put a legend in there so you can make sense of those colors, right? Easy enough. Let's put that on the right. Okay, so we see on here now, we've got our axes labeled. This is our x-axis, our y-axis. Our y is tomato yield, x is tomato variety. You know what each of these three colors means. This is each variety listed. Okay. What are we missing? We know that we need error bars. That error bar is going to bring standard deviation into this story. So I'm going to select these. Oh, let's see. No, let's do it differently. I'm going to undo that. I'm going to add chart element. Once I have just one of these selected, you can probably access that through that plus button too. I'm going to access it through here, add chart element, go to error bars. Let's click more error bar options. We've calculated exactly what we want our error bars to represent. So let's put them in that way. This will take a second to load, but you'll see this box popped up all of a sudden. Let's do a custom, specify a value. We have a positive and a negative. That's the upside and the downside. It needs to be the same value for what we're doing. So let's select this. That's our matching each variety, right? That's our standard deviation. And our standard deviation again. Okay. All right, we got our first error bar in. Let's repeat. Now, if you have the same error bars across all of these, you should take a second look. If your error bars look identical across your varieties, that's probably a problem, right? That means you didn't do something right. So go back through this video, click the rewind button, and go ahead and take some time to figure it out, because you'll need this later throughout the semester. Notice this error bar is smaller than that, right? Easy enough. Okay, that's all we need for this first graph. Let's repeat it for bricks. We'll click Insert, Graph, 2D column, do that clustered column option. Just kind of put it in that yellow box area. I'm going to right-click, hit Select Data. And again, we're doing the same thing, but for bricks. Do this one legend entry at a time. Series name is that variety. Series value is the mean bricks. And we'll repeat. I'm going to slow down a little bit when I do this, just to make sure you see what cells I'm clicking exactly. They're kind of highlighted after I click them. Okay, so we're at this step. We need to add our axis labels on the X and on the Y axis, right? X axis, Y axis, horizontal, vertical. Axis titles, we're in that chart design section. Primary, horizontal, and primary vertical. So they're just labeled as axis title right now. This is going to be bricks as a percentage. Oops. This is going to be tomato variety. All right. You can just click that one, hit the delete, get rid of that. We're going to add our legend, right? When you make sense of those colors. Same as that. If it's not the same, take a minute to reevaluate. Click on your cell, your bar, add chart element, error bars, and you know what to do from here. More error bar options, custom, specify. We have that positive and negative for each variety, so make sure you have those matched up. Okay, that's it. That's all we have to do for these first two graphs, right? We've made our bar graphs. They tell us really important stuff. They make sense of this huge data table that we don't know how to deal with. Just glancing at it real quick. They put it in a way that's visually appealing. and that we can interpret all of, right? We know what these values mean. We know what these bars mean. These bars are the mean for each variety. We know what these error bars mean. It tells us the standard deviation, the amount of error in that data. Okay, this final part's a little tricky. This final part addresses that hypothesis question, that question of, is there an association between yield and bricks? So we're going to click the insert. Instead of clicking this bar or insert column or bar chart, let's insert a scatter plot. And just this scatter 2D plot is all we need. And of course, I'm going to match it up here because I think that's kind of a fun thing to do. Okay. Now, right click, select data, and take a minute to think about what you need to select. We're going to do that regression analysis, right? So I'm going to add series name. Series name, it doesn't matter too much. Regression of yield and bricks. Okay. X-axis, this is our x-axis down here. We'll have that be bricks. And we'll select bricks for the mean of each variety. Actually, I've changed my mind. No, we're going to keep it that way since I've already said it. We can just do this number here, select all three of them for varieties 1 through 3. And for our x-axis, we do that same thing. I'm sorry, for our y-axis, we do that same thing, but for yield. Select those three, each variety. We'll see that each variety should show up as a dot on this regression, if I did it right. And indeed I did, right? So this tells us it's 4.525 and 44.225. 4.525, 44. This is that first dot here. I'm going to highlight that, and I don't know, blue's a fun color. This next dot, this is 5.35 and 34.95. Aha. We'll make it, I don't know, golden. This final dot, 6.225, 30.15, 30. Okay, we did this correctly. This is good news. If we didn't do this correctly, I'd have some other problems. All right, what's missing on this graph? You, I'm sure, know the answer, right? Chart design, add chart element, primary horizontal, primary vertical. This is yield in units of tons per acre. This is bricks as a percentage. All right, I still don't like this graph too much. I want to zoom in on what's important to me. We want to talk about this association between yield and sweetness for these tomato varieties. So let's change these axes. No, we were in the right spot. So we want to start with that horizontal axis value. Click this option here, if I can remember this correctly. Here we go. For our axis options in these bars, once we've gotten here, maybe let's redo that. Let's go there one more time. In this drop down, we're clicking horizontal value, axis. We've clicked this fourth tab. We have options for bounds. We're currently going from 0 to 7. Let's go from 3 to 7 and really zoom in on what we're interested in. Let's zoom in a little bit more. I don't like that. Let's go to 4.0 to 6.5. Okay. And this gives us a pretty good story. We can repeat this. Let's repeat this one more time. I think this is fine. So let's add trend line. I've selected these dots. I right-clicked on them, hit add trend line. I'm going to display the equation and display the association. Now this gives us, more importantly than this equation, it's just an equation. It gives us an R square value. I'm going to zoom in on this just a little bit so you can really see that. That's telling us that there's a really strong association between yield and sweetness in these tomato varieties, and it's a negative association. That means the higher yield we have, the lower the sweetness, right? The reverse is true. If we have a low yield, we're probably seeing a high sweetness in here. And these R square values will range from, for what we're doing, 0.00 repeating to 1.00000. And that's because we're taking that R square value, right? Those should all be positive since it's squared. So having it this high means that there's a really strong association. Now, I'm going to go through and edit this value real quick, but if I were to go to Juliet and turn that yield from 44 to 12, that reflects here, and we see that there's a positive association in the opposite direction, right? Not quite the right answer there, right? This is the answer from the actual data that we have. So that's it for that. Let's take a second to look at the practice. Now this practice does the same thing, a lot of the same stuff, but focuses on fertilizer rates. Graph number 5 will be tricky, but I advise taking some time to figure that out. You're really making a yield response to nitrogen rate graph. Good luck with that. And that's it for today. This is posted on Blackboard. Take your time going through it, and I will see you all next week.